Sedimentary facies, transgressions and regressions. Facies, no, I did not misspell this. It's not facies or facies, it's facies. A facies is a unit of rock with characteristics that correspond to a particular environment. Now the characteristics could be the size of the sediment, or it could be the rounding of the sediment. It could be whether you have cross-bedding. It could be whether you have ripple marks or fossils. All of these will tell you something about the environment in which the rock formed. Let's say you're lucky enough to go to the Wave. The Wave is an amazing formation on the Colorado Plateau of Navajo sandstone. The cross-bedding on this sandstone, which is pretty dramatic, tells you that this could only have formed in an environment of huge sand dunes. Well, let's go to the Grand Canyon, shall we? We'll start up here on the Kaibab Plateau and hike all the way down to this area here called the Tonto Group. The Tonto Group contains 3 different rock layers that were formed one after the other without erosion in between. The first one we're going to encounter is the Moab limestone. Now the limestone formed in a deep ocean from the calcium carbonate shells of marine organisms. Let's hike down a little bit further. We will encounter the Bright Angel Shale. Shale, as you know, is formed from mud, and this mud came off of a continent. So it must be a lot closer to a continent than that limestone was. Going even further, we encounter the Tapete sandstone. This sandstone will have evidence, little trilobite fossils, that it was formed at the beach. We've got 3 different rock layers forming in 3 different environments: the limestone, the shale, and the sandstone. So we have now determined that the limestone, Bright Angel Shale, and the Tapete sandstone formed at these environments. Does that mean we're done? Of course not. There's a lot more of this left, because there's a problem here. We find that the deep sea sediments, the limestone was formed at the top, on top of shale, on top of sandstone. Well, how did that form? Well, I'm going to tell you. Let's go back to our limestone, shale, and sandstone forming at the deep ocean, shallow ocean, and the beach. I'm going to add to this one more layer, a conglomerate that could have formed from rivers on the continent. Here we have our layers forming, and we're going to have sea level rise. Well, why did sea level rise? Could be a number of reasons. It could be because of ice ages. If the ice age is over and the glaciers melt, sea level will rise. It may not be the sea level rising per se, but the land going down. That could be because of tectonics or isostasy. It doesn't really matter for our purposes here what caused sea level to rise, but sea level does tend to rise and fall over time. And in geology, we have lots and lots of time. Notice that the deep ocean is over the old layer of shale. Well, that's not going to do at all. We've got the wrong sedimentary rock underneath it. So as more sediment is forming, you're going to see the facies start to shift, in this case, shifting to the right. Now the shallow ocean is forming shale, and the beach is forming sandstone. Well, let's raise the ocean even further and look see what happens. The facies have shifted over even more. In some places, you have sandstone and shale and limestone, one on top of the other. One on top of the other. Doesn't that sound familiar? Indeed. That's what happened at the Grand Canyon. We had Moab limestone on top of Bright Angel Shale, on top of sandstone. Mystery solved. So this is called a transgression. As sea level rises, you can end up having deeper sea sediments making rocks that are on top of shallow sea sedimentary rocks. What if instead you've got shallow rocks over deeper rocks? You guessed it, sea level must have gone down over time. And that is called a regression. So a transgression happens when you have sea level going up, causing deep rocks to be over shallow rocks. A regression happens when you have shallow over deep because sea level has gone down. Let's compare the Navajo sandstone with the Tepic sandstone. They're both sandstone, are they the same facies? Well, they look really different. So no, they're not the same facies at all. After all, the Navajo sandstone with its cross-bedding formed in a desert, and the Tepic sandstone formed in an ancient ocean each. Let's instead look at two layers of limestone, the Kaibab limestone found at the top of the Grand Canyon, and the Moab limestone found further down. These two look alike, and they formed in the exact same kind of environment in a deep ocean. These are the same facies. But are they the same formation? No. They're given different names. This is called the Kaibab Formation, and this is the Moab Formation. They're different formations because they formed at different times. The Kaibab limestone is much younger than the Moab limestone. So a formation is a distinctive layer of rock formed at a particular time in a particular environment. They must be the same facies and the same age. They don't have to be the same thickness, however. You can find the Kaibab limestone on the top of the Grand Canyon or a thinner layer of Kaibab limestone at the bottom of the Hurricane Fault. They are, however, the same formation, they're distinctive, and they were formed at the same time in the same environment. So that's a formation, folks, and that's all.